Anytime you raise or lower the suspension of a vehicle, which is to say anytime you change the geometry of the driveline, you'll need to set the pinion angle for the front and rear axles. This video will show you how to measure the pinion angle and where it should be measured to ensure you get accurate readings so you get good results when you adjust the pinion angle. Tools needed: floor jack, jack stand, 2 lengths of 2x4 to serve as chocks for the vehicle's front tires, an angle finder, or a protractor as it's commonly called. We'll need a piece of paper and a pen to record the values that we measure. We'll also need an 8mm socket, a 15mm socket, an 8mm wrench, a 15mm wrench, a ratchet, torque wrench, and either a long screwdriver, a lever, or an extension of some kind to serve as a pry bar when removing the rear drive shaft from the harmonic balancer of the transfer case. A small bottle of white touch-up paint can come in handy as well for marking parts of the drive shaft. In order to eliminate driveline vibrations, the goal is to make sure that the angle made by the transfer case output relative to the drive shaft exactly mirrors the angle made by the drive shaft and the rear axle. If the angles made by the drive shaft and the rear axle, as well as the drive shaft and the output of the transfer case, mirror each other and are the same, driveline vibrations will be canceled out and the Jeep should drive smoothly down the road. Before we begin, it would be wise to mark a few items so that when we put it all back together, everything goes in the right place. I like to use a little bit of white touch-up paint for my markings because I find it's the easiest to see, and you don't have to be too precise. As long as you know what part goes where, it'll work. So here I've just marked the harmonic balancer as well as the forward end of the rear drive shaft where it attaches to the transfer case. Next we're going to remove the 4 bolts that secure the front of the rear drive shaft to the harmonic balancing assembly of the rear output of the transfer case. Because of the location of the stock muffler assembly, you probably need to rotate the rear output of the transfer case in order to access the 4th bolt on the right side of the vehicle. We'll do that by jacking up the rear axle of the Jeep, putting the transfer case in neutral, and rotating the drive shaft by hand. Again, make sure that your parking brake's not set, transfer case is in neutral, and that the front wheels and tires are securely chocked. In order to loosen the last remaining bolt, we'll need to make sure the tires of the rear axle are back on the ground in order to hold the rear drive shaft and thus the rear output of the transfer case stationary. Having removed the 4 bolts securing the front of the rear drive shaft to the rear of the harmonic balancer for the transfer case output, we can now remove the drive shaft from our harmonic balancer. While sometimes it'll come off with a firm tug, it's going to be easier if you use something to pry it off. I've found that the tip of a socket extension fits nicely there and will easily pop the drive shaft off of the harmonic balancer assembly. We now have excellent access to measure the angle of the rear output shaft of the transfer case along the face of the harmonic balancer. Place your magnetic protractor along the rear face of the harmonic balancer and measure your angle off of vertical. In this case, we're approximately 6 degrees from vertical. Before we reinstall the front of the rear drive shaft, just take a moment to make sure that any vibrations you might have aren't caused by a worn-out U-joint. In this case, this is as it should be. In both planes of movement, the U-joint moves with a fluid hydraulic resistance that's very consistent. If you find any play in any direction, it's probably a good idea at this point in time to replace that U-joint while we have access to it. Also, make sure that there is not a significant amount of play in the splines of the slip joint. It should move easily in and out with very, very small amounts of play in either direction. Using a medium strength thread locker, which is usually denoted by the color blue, apply 1 drop of thread locker to the threads and install each bolt, torquing it to 85 foot-pounds. Make sure you mark the drive shaft, the rear axle yoke, and the straps that secure the caps of the U-joint. Once you've marked everything, take a minute to make sure that the orientation of the rear axle yoke at the rear axle pinion is within a few degrees of vertical. To get the most accurate readings for the value of the rear axle at the pinion, it will be easiest if you remove the rear drive shaft and U-joint. So to do that, we're going to use our 8mm wrench and remove the 4 bolts that secure the caps over the U-joint. Because of the angle of the drive shaft, it may interfere with being able to use a regular socket wrench, so sometimes a box wrench can be handy to get to these. Now carefully remove the rear drive shaft by pushing forward and laying it down. Now with this exposed, we can place our angle finder, our protractor, across the face of the yoke and measure the angle. Place the edge of the protractor firmly against the axle yoke and record the angle that you read. In this case, we're at 5.5 degrees from 90. If you lengthen the lower control arms here, it will push the axle back, which will bring the nose of the pinion down. So by pushing this back, it rotates the angle down. If you find that the angle is too far down, which after lifting it probably won't be, then you'll need to bring it up, and you do that by shortening your lower control arms. If you have adjustable upper control arms, if you shorten the control arms, that will bring the nose of the pinion down, and if you lengthen them, it will bring the nose of the pinion up. Since the rear axle pinion will rotate upward when under drive torque, adjust the rear pinion to point approximately 1 degree further downward than the angle of the transfer case output. This will allow the driveline to come into proper alignment when under load.